I don't want to talk about people's potential activities while we're recording. Okay, so 12.9 is area of triangles. You guys have obviously covered area of triangles when, probably in elementary school at some level or junior high, and then in geometry we definitely did. The area formula of a triangle is 1/2 base times height, right? So it's the area of a rectangle and then divided by 2. That's where it comes from. And that works well when you have triangles that look like triangles that you know the altitude to, meaning you have either it's a right triangle like this, and you know that this is 4 and this is 7, easy to do, or a triangle that looks like this, where it's not a right triangle, but you do know the altitude, and the base is 15, the altitude is 3, something like that. Those are easy triangles to find because, area is equal to 1/2 base times height, or, area is equal to 1/2 base times height. Okay, so that's easy. Well, what happens when we don't have the altitude? We don't have the altitude. Can we still solve for the area? And there is, with some trigonometry, we can find area of triangles with so for non-right triangles, and you can actually use it with a right triangle, but why would you when you can just do this with a right triangle? So the area formula is, one of them is K is equal to 1/2 AB sine of C. Again, I'm not going to make you memorize these. I will give you these formulas. All the other trig stuff, SOHCAHTOA, you'll need to know those. But this one, these ones you won't need to know. So if you have 1/2 AB sine of C, and if you think about what that would be it would be if you had a triangle that looks something like this, and we'll call this C, A, and B. So this would be little a, this would be little b, and this would be angle C. So 1/2 AB sine of C, right, the angle measure. So that's if you're given SAS, side angle side. If you're given SAS, you can solve for the area. Now, if you think about that, and we change this to a right triangle like this, and we still labeled it as C, and we said A, or I'm sorry, we'll go B and A like this. And we said, okay, well, right triangle, could we still use the formula? Sure. It would be, K is equal to 1/2 AB sine of C. Well, if C is 90, it would be the sine of 90. What's the sine of 90? 1. So 1 times anything is just itself. So it's 1/2 AB, which is base times height, which you write back to base times height. So it can work with a 90, but it wouldn't make any sense too. But it's and that's where it stems from. There's a proof behind it where these formulas come from, and it comes from that concept of coming up with the altitude. Actually, like an altitude like that. So that's where it stems from. So that's one of the formulas. The other formulas, I have to look up here. That's the one I remember. Now it could be any. I just wrote AB sine of C as long as it's side angle side. So if I have side C, it could be 1/2 AC sine of B. I'm not going to write all those for you. Just as long as it's any side angle side. Or it could be 1/2 BC sine of A. It's all the same formula. The other one is K, and by the way, K is just another way to write area. They probably use K for area because they're using angle A for some of this stuff, right? So rather than having A for area and A for an angle, they use K for area. The other one would be 1/2 A squared. And then it is sine B sine C all over sine A. So this would be if you know all 3 angles and then one side, you could use this formula. Now, if you knew side B instead of side A, then you would just put B here, and then instead of A in the bottom, it would be B in the bottom, A would go on top. Or if you do two angles and a side, because if you know two angles, can you find the third? Yeah, so two angles and a side, because to find the third angle, subtract from 180, right? So two angles and a side will allow you to solve for that. So if you just know one side and two angles, you're set. The last one, which is a little more extensive because it's a two-part thing. If you know all three sides, if you know all three sides, it would be equal to k is equal to the square root of s times s minus a times s minus b times s minus c. So the sides are a, b, and c. We understand that. What is s? Well, s would be equal to additional formula, 1/2 a plus b plus c. Like that. So if you know all three sides with no angles, you can still find the area and do it that way. So if you have like coordinate points, for example, you know, in geometry we don't do this because we don't have all the trig stuff. This actually isn't any trigonometry, is it? No, you just have to know all three sides. But there's no trigonometry with it. But if you're given three coordinate points like this, and you needed to find the area, you could just do the distance formula and find the three distances, and then add them all together, divide by 2, and then plug in s, and then subtract them, and then solve. Take the square root of it. So, but there is a way to solve for that. But that one is no trig. It's just if you know all three sides. So that's kind of cool, is that they came up with all these different ways to find the area of a triangle, even without knowing the height, without knowing the altitude. So that's all the assignment did, is using these. Now, you'll have to remember some of the your geometry stuff, which is things like what a rhombus is, or parallelogram, or things like that. So let's do this. Let's talk about if you have the area of a rhombus has perimeter 48 and an angle of 55. So if you have a rhombus and you want to find the area of this rhombus, so the rhombus has perimeter is equal to 48 and one of the angles is equal to 55 degrees, they tell you. Okay. For starters, let's review. So we're going to find the area of this. What is a rhombus?
All sides are the same. Four sides.
A diamond, right? All four sides are the same. So is a square a rhombus?
Yes.
Yeah. Are all rhombuses squares? No. So, with an angle of 55, we know it's not a square. We think of it more like the diamond, right? Like Eliana said there. So not the best rhombus. Just a little bit, maybe like that. That's a little better. So you have a rhombus. Perimeter is 48. So what does that tell you about the sides?
12.
Yeah, because they're all the same. So okay, 12, 12, 12, 12. And then if an angle measure is 55, it doesn't, the picture sets it up where this angle would be 55. Okay, so if I want to find the area, is that enough information? There's actually an area formula for it. I'd be amazed if anybody runs the area formula for a rhombus from geometry. It's 1/2 diagonal 1 times diagonal 2. So there is a formula for it where it's this times that divided by 2. That's not what they're looking for you to do. They're looking for you to look at that and then utilize one of these 3 formulas.
Well, so should we cut it in half, maybe, to To make a triangle.
Yeah, you bet. So let's just cut it in half. So now I have two triangles. Are the triangles the same?
Yes.
Yeah, triangles will be the same. So find the area and then just multiply by 2. So what are you given? You're given a side, an angle side. Nice. So you're going to go, it's okay, I'm given SAS. So therefore, I can just go side angle side. If you look up here, notice I just said 12 times 12 times sine of 55. What happened to the 1/2?
Do we not have an altitude?
We don't need an altitude, because for the trigonometry we just need a side and then an angle and then a side, which I have, right? A side, an angle, and a side.
Because we cut it in half.
Yeah, you cut it in half, so you have two triangles, you're going to multiply it by 2 anyways. So 2 times 1/2 is 1, and so essentially that's, I mean, you could divide it by 2 and then multiply it by 2. It's, you know, it'll be the same answer. I just multiplied it by 2. Now this one, would I say give it to me in exact form? No. When would I say give me something in exact form? I say, hey, I want answers in exact, the simplest radical form or exact decimal form even.
When we use third formula.
No. Third formula, I see what you're saying, because you'd have all 3 sides and you got a square root symbol.
Yeah.
Exact, okay? 30, 60, 90s or 45, 45, 90s, right? Unit circle stuff. 55 is not a unit circle value. So when you're dealing with trigonometry, when you see something or, you know, somebody, or, you know, somebody says, oh, I want it in exact radical form, it's got to be a 30, 60, 90 or 45, 45. So 55 is not, you're going to have to use your calculator. If this was 45, do you need a calculator? No. Now you would get a decimal format out, but if it was 30, if it was 60, if it was 45, you wouldn't need any calculator, or 150, right? Something like that. Now, with this rhombus, there's other ways you could have done it. You could have said, hey, if I know this is 55, what do I know about this angle? 120. 125?
25, yeah.
Or, yeah, 125, right? And so then you could say, okay, I could split it that way if I wanted to, right? You could split it this way, go side, angle, side, multiply by 2, you'll get the same thing. Which makes absolute sense.
Yeah.
Because 55 degrees, right? And then what's this over here? 55 degrees, because it's a reference angle, and sine is positive here, and sine is positive here. So the sine of 125 is the same as the sine of 55 from the reference angle stuff.
Oh, yeah.
Yeah, so that's why the formula would work both ways. You could also say, okay, this is 125. If you cut this in half like this, which is the diagonals bisect, this becomes 60, what, 2.5 degrees? I'm not saying you need to do this, but you know, this is other ways. 62.5, this is 62.5. Now you know all 3 angles and you know a side. So you could, I mean, this is more work, but you know, you could go, okay, I know all 3 angles, 62.5, 62.5, and 55. And then I know one of the sides is 12, and you could do that route too. That's longer. I wouldn't do that route, but there's other options. What did you get for K, by the way? Make sure we.
117.95.
117.95. Okay. Seems reasonable. Okay. If you're given, let's do another one. ABC. Triangle ABC, or my box it. You know the area for triangle ABC is 20 units squared. And they tell you angle A is equal to 130 degrees. And then they tell you B is equal to 6. and then they say C is equal to unknown. So what do we want to do here?
The first one.
So we're
Side and side.
your side angle side, yeah. So you're given an area, you're given an angle, you're given a side, so you're missing the side, so then you can solve that way, right? By saying 20 is equal to 1/2 BC sine of A, so B, 6 times C times the sine of 130 degrees. And then you just solve for C. So that would be the setup for that one. Again, not exact values because sine of 130 is not a unit circle value. So what do you get?
8.7.
8.7? Seems reasonable. I mean, 8.7, if B was 6, 8.7 seems reasonable. Okay, I'm going to go with it. The book agrees with you. Okay, here's one for you. Area of a regular octagon inscribed in a unit circle. Okay. I mentioned something about the unit circle at one point, I'm pretty sure, although maybe go back and watch the lectures and be like, yeah, you never said it. But that's okay, I'll tell you now. Or maybe remember. But they would help us solve this problem. So we see there's actually no numbers listed, right? We do see an octagon, that's kind of a number. How many sides is an octagon? 8. So we know we have an 8-sided figure. Now we need to analyze a couple things about this. Words to analyze that we need to know. Octagon, most people know. 8-sided figure, we're good there. Circle, people understand that. Specifically a unit circle. So that sometimes might throw you off. You might be thinking 30 degrees, 60 degrees, radians and all that. I'll give you a pro tip on the unit circle. We know what a circle is. So words that we already know, we know octagon, we understand that. We know circle, we understand that. So we know we have a circle, they're talking about a circle, okay? Inscribed, let's talk about what does inscribed mean?
Inside.
Inside, but what do we mean, like?
The edges are touching.
The edges are, yeah, the vertexes are all touching. That's what inscribed means. It's not just inside, it's in, and you probably may have been thinking that, but okay, so inscribed means vertexes, one, like this, so on and so forth. Now, we've got inscribed, we got circle. The two things that when we understand area, we know what we're trying to find. Words that we're struggling with, regular and the unit part. Now we know a unit circle is 30, 45, pi over 6, those types of things. But let's talk about regular. What does regular mean?
All the angles are the same.
All angles and all sides are the same, you bet. So all angles and all sides are the same on this. So, here the picture's poor, and it's not terrible. It's not actually good, but that's fine. So all that means this is the same, this is the same, this is the same, this is the same. Those are all the same. And then all the angles are the same, whatever the angles are. Now there's a way to find out what the angles are. Anybody know what this angle measure is? I mean, these are all the same, whatever they are. There's a formula, which you actually, in the end, you wouldn't need to know this formula, but there's two ways to go about it. The sum of the measures of a regular polygon is equal to 180 minus n. I'm sorry, not 180. It is 180, I just wrote it the wrong way. It's 180 times n minus 2, where n is the number of sides. And you memorized that in geometry briefly, but you think about this. This is the sum of the angle measures in a regular polygon. So if you had 3 sides, 3 minus 2 is 1. 1 times 180 is 180. That's because it's a triangle. How many degrees are in a triangle? 180. If it's 4 sides, 4 minus 2 is 2. 2 times 180 is 360, because there's 360 degrees like in a rectangle, right? So whatever. So now you plug in 8. 8 minus 2 is 6. 6 times 180 is 1080.
Maybe.
1080. So there's 1080 degrees in an octagon. Since it's regular, what's the angle measure of each angle?
130.
135, right? So the other way you could do that, so we know each angle measures 135 at each vertex there. Now, the other way you could do that is that there's another formula that states this, and that is in any regular polygon, the exterior angles, like if you were to extend off there, the exterior angles, those are all going to be the same as well, right? And there's 360 degrees and then in exterior angles. So an octagon has how many exterior angles? 8. So there's 8 thetas, and we know all of them, no matter if it's an octagon or a pentagon, they're all going to always add up to be 360 degrees for the exterior. Which makes sense, because if you think about, you start with like a quadrilateral, and then as you add more sides, octagon, pentagon, a 40-sided figure, essentially as you make it, the angle becomes bigger and bigger, right? Because if you had like 40 sides, it would be, something like this, right? What does the shape essentially become? Yeah, it essentially becomes a circle. And how many degrees in a circle? 360, yeah. So theta goes into 360 how many times? Or 8 goes into 360, I'm sorry.
45.
45, which would then tell you that the exterior here is 45, which would have told you the interior is 135. This is like some excess information, but it's like all the stuff from geometry that we are trying to like review. Okay, so now we check the box. We understand regular. Remember this formula, which you wouldn't have to know for the test. We remember this, which you wouldn't have to know for the test, but we'll get there. Now, when you think about, we want to find the area of this. The issue is I know some angle measures, but I don't know any sides. Now, when we eventually talk about the sides, we'd have the center, right? And then in a circle is full of radiuses, which I'll draw this in red. The radius, right, is going to come from the center and go out to here and out to there, right? So the radius is going to be the same. Now, when you think about this, although the picture may be kind of poor, how many of these triangles are going to be in the octagon? 8, and they're all going to be the same. So if you could find one area, multiply it by 8. So I know that if this is 135, because it's a regular, it's going to get cut, right? It's going to get cut in half, right? And so 135 divided by 2 is going to be? 67.5. Okay, so now we're back to 67.5 and 67.5, right? The other way we could have done that is to recognize that it's going to be an isosceles triangle. This triangle right here is isosceles, right? If you didn't know the 135 part, because you didn't know this formula, and you could say, oh, well, wait a second. How many triangles do I have here? 8. How many degrees are in here? 360. So 360 divided by 8, we already analyzed over here, was 45. So you could have said, oh, this angle is 45 degrees. And therefore, isosceles triangle, this is 67.5 and 67.5. Okay? So now really what you're looking at, I'll draw the triangle, you're looking at this and this, 67.5, 67.5, and 45. Great, you know all three angles, what do we still need? A side, right? It's going to need to know how big this triangle is. Because this is if you know all three sides, all three angles, but you need a side, two sides and an angle. Okay. Unit circle, we're back to, this is a great analysis of this. We've gotten back to the only word that's hanging us up, it's the key to our information is unit circle. Unit circle, in trigonometry, it doesn't matter. Like when we talk about a 30, 60, 90, it doesn't matter if your hypotenuse is 20 or 10 or whatever. The ratios are always the same. The sine of 30 is always going to be what? You could use your calculator to remember the unit circle. Sine of 30 is always 1/2. The unit circle, if you don't remember this, I'm going to tell you now, what is the R value on the unit circle? What's the radius value that they use to make your life easy? 1. So when you say unit circle, it has a radius value of 1. To understand the trigonometry, it could be a radius value of 15. It doesn't matter because it's a ratio. But remember when you're doing sine, it's y over r, cosine is x over r. Isn't it really easy to divide by 1? So it's like y over 1, x over 1. It's just easier to divide by 1, but the ratio is always the same. So there you go. Unit circle means a radius of 1. So what do you know? This radius is 1, this radius is 1. So this is 1 and this is 1. So now, could I reasonably say find the area in exact format? No decimals, only radicals. Absolutely. Not because of the 67.5, but because of the what? 45. So I could say, hey, SAS, side angle side. So you're going to say area is equal to 1/2 AB sine of 45 degrees. Then you're going to multiply the whole thing by 8. Okay, we'll get there. So why no calculators, exact values? Well, what's the sine of 45? Root 2 over 2. So the area of one triangle is equal to root 2 over 4. Multiply that by, for the area total, multiply it by 8. And so what's your answer equal to? 2 root 2. And there's your answer. Now the book answer is going to actually give you a decimal value, and that's fine. I always say this because I want to be able to at any point say, hey, exact values, and force you to remember. I probably won't on the test, but you know, I could. So, okay? A lot going on there. Aim for the test Thursday. Realistically, we probably won't grade this tomorrow, but you could. You only have 1 through 15 odd on it, so. But we'll probably delay 12-8, 12-7, 12-8. We'll grade tomorrow for sure. So make sure those are done. This one, probably work on in class tomorrow.